afternoon, everyone. Thank you very much for attending today's LEEPout webinar. Today marks a special occasion for us at LEEP because we launched the LEEPout seminar series exactly 1 year ago, so that's an important anniversary. It all started as a short-term solution to the isolation we were all unfortunately forced into due to the pandemic, and then it grew into something bigger. In fact, in a year, we hosted 10 excellent speakers in environmental economics, and we had more than 500 attendees in total from around the world, which is absolutely fantastic. We weren't envisaging that for sure, so thank you everyone who made this possible, and especially the speakers and the attendees and the rest of LEEP as well. So to mark this important anniversary and milestone, today we are very privileged to have John Whitehead, professor in environmental economics at Appalachian State University in North Carolina. Thank you very much, John, for joining us today and making the time for the presentation. As many of you will know, John has contributed with some significant advances, especially in the field of the non-market valuation of the environment in the context of recreation, water quality, and more recently also sports. His research focuses primarily on combining revealed and stated preference data to better integrate the environment into economic decision-making and analysis. And in this area, John has published more than 100 peer-reviewed articles in journals like the American Journal of Agricultural Economics, the Journal of Environmental Economics and Management, Land Economics, just to name a few. John is currently Vice President of the Association of Environmental and Resource Economists and is on the editorial council of the Journal of the Association. Today, John will present some recent research focusing on the joint estimation of recreational demand models, combining revealed preference and stated preference discrete choice experiment data in the context of marine fishing. And in particular, he will discuss some of the advantages of combining these two methods and ways to overcome some limitations, particularly in relation to attribute non-attendance, which is a problem that sometimes stated preference methods can be prone to. So before we start, I just wanted to remind all attendees that today's presentation, including the Q&As, will last an hour in total. We will try to keep questions for the end, for the last more or less 15 minutes of the slot. And during the talk, we will only try to take urgent clarification questions that cannot wait until the end. So if you have questions or want to share any comments, use the chat function, please, or the raise hand functionality. We invite everyone to please keep the microphone muted as well, which I think is the case just to avoid interference. And by now you will all be aware that this seminar is being recorded as well, and we will make the recording available later on our webpage. So without further ado, I would now like to warmly welcome John and leave him the floor for his presentation. Thanks, John.
All right, thank you, Michaela, for that nice introduction, and thanks to Michaela and Ben for inviting me, and thanks everyone for showing up today. I'm real excited about presenting this paper. Let's see. Okay, so we're going to do it this way. I told you, Michaela, that it would be a problem.
No worries at all.
Okay, so here's how I do it. I share this screen and then I put it into presentation mode, and then I do a new share, and I think y'all can see the presentation now.
Yeah, it's in
All
presentation.
right, okay, great.
Mode. Yeah.
Okay, so first, apologies to one of my co-authors, Reza Zarai at University of Georgia. He was left off the abstract that I sent earlier this spring. Reza's a graduate student at the University of Georgia, and I just don't know him as well as the other guys, and I just forgot to put him on the abstract. So he is a co-author and has made a significant contribution. So it's good to have him as one of these co-authors. This is a great group of co-authors, and I lean into them a couple times during this talk. So the fish you see here is that's a red snapper. That's an important commercial and recreational fish species in the United States, and that'll be the fish that I talk about most during this. And let's see. Okay, so I've posted a draft of the paper. There's the website, and I also put that in the chat if you can find that. If you'd like to have a paper in front of you during a seminar, that's there. The paper is, as I'll explain later, is carved out of a report from over 2 years ago. We submitted the report and just were totally sick of it and let it sit. And I was real happy to have a chance to present it. So the story behind the paper is kind of a long one, and I've been around a while, and I've gotten to where I like to tell these stories. So I hope you can bear with me as I reminisce. So I think the story for this paper began in 2010 at a National Marine Fisheries Service Economics and Social Science Workshop. National Marine Fisheries Service is the federal agency in the United States that regulates commercial and recreational fishing. And David Carter presented this paper in 2010, and it came out in 2012. And he did a great job. Afterwards, I went up to him and we were talking about it, and I said, this is a stated preference paper. I said, the reveal preference data for each of your survey respondents is sitting on your computer somewhere, and you can link them up and jointly estimate that model. And he said, well, why don't you write a grant and propose to do that? And I said, okay, I will. And that first grant went on to be rejected. We revised it and finally got that research funded, and that's what I'm talking about today. So at the time, say 2010, the joint estimation of reveal preference and stated preference data had been a topic for a good amount of time. So this is my own history of RP and SP joint estimation thought. It began with a paper, in at least environmental resource economics, written by Trudy Cameron and Land Econ in 1992. Just a fantastic paper. The first academic conference I ever went to, I went to the session where she presented that. And about the same time, Vic Adamovitz, Jordan Louvier, and Williams had a paper come out in Gene, which the screenshot is on the right. And I think it's long enough ago that I can say that I was one of the referees of that paper, and I didn't fully understand what they were doing, and I did my best with the review, like we do a lot of times. But this paper is about the same thing that we're doing with the current data. Okay, and what they had reveal preference data and stated preference data, and they estimated a distance coefficient, which instead of transforming that into a travel cost coefficient, they just kept it as distance. And so their coefficient estimates, you can see here, the reveal preference coefficient estimate in absolute value is 4 times as great. Okay, so when I went back and looked at this paper this week, I was struck by the fact that this is about the same result that we have right now. These days, I would interpret this as a state of the survey respondents were not paying as much attention to the stated preference distance to the recreation site as the reveal preference folks did. And when they jointly estimated their work, they came up with a coefficient that's much closer to the reveal preference data. Okay, and then in 1996, there was an ARI workshop, and this is the workshops were the precursors to the ARI summer conferences that we have today. There's no, you can't find this on the internet, so I had to go back to the Wayback Machine and look at old ARI web pages. And here's a bigger screenshot. You might be able to read this. So in 1996, the workshop was combining stated preference data and reveal preference data to estimate the demand for and or benefits from environmental amenities. So not much different than a title you would see right now. And at that workshop, I had a paper with Tim Hab and Ju-Chin Wong, and it got rejected. We were all assistant professors at East Carolina University, and somehow we all got funding to travel to and attend the conference in Lake Tahoe, which is a beautiful place on the other side of the United States. And I, sat there and listened and was just fascinated by what was going on at the workshop. The main thing that came out of that was we had this scale parameter in these conditional logit models, and you have to do a lot of work to combine reveal preference and stated preference data because the scale parameters are different. And so I'll talk some about that, and maybe talk a little bit about how I don't think that's such a big deal anymore, or it should be considered such a big deal. Okay, so 10 years later, I organized a session, an ARI session at the ASSA meetings called Joint Estimation and Environmental Evaluation. 10 years later, with papers presented by Roger von Hafen and Sabrindu Patanayak, Kevin Egan and Bill Breffel, and they covered a lot of the range of joint estimation. In the discussants, you can see an all-star cast of discussants: Trudy Cameron, Vic Adamovitz, and Jordan Louvier. And I think I was excited about this session because it really illustrated the opportunities that folks have with joint estimating different types of stated preference data with reveal preferences. And so following that, Tim Hab and Ju-Chin Wong and I edited this book, Preference Data for Environmental Evaluation, Combining Revealed and Stated Approaches, that really showed the range of opportunities with these two types of data. So that really didn't have this book doesn't really have the intellectual heft as the Cameron Adamovitz et al. Papers, but there's a lot of applications there. And so there's just, I'm plugging my book. So, but this talk, so now it's 10 years after this book came out. And I'm interested in what's happened since then. And I don't think much has. So my story goes on to 4 years later. So that was where my mind was 4 years later, when NMFS, National Marine Fisheries Service, NOAA Fisheries, had another workshop. This one was a constituents workshop. And during that workshop, the National Marine Fisheries Service economists presented their data holdings, the reveal preference data. They called it their economic valuation questions on their Creel survey. And then they talked about their stated preference surveys. And I was given, on the second day of the workshop, I was given the opportunity to be on a panel to wrap things up. And I guess I felt like I could say whatever I wanted. And when the workshop proceedings came out, I was surprised to see that there was a scribe who was capturing comments, and these are some of the things that they said. I said. I was concerned that my random utility model. This was not mine. It was with Ted McConnell. A reveal preference random utility model that was conducted for the National Marine Fisheries Service to value groups of recreational species. We conducted it 15 years ago, and it was still being used in fisheries management plans. And it was an old paper, it was outdated. The nested logit model was a two-stage model, and I felt that they could do better. I felt like the National Marine Fisheries Service jumped into stated preference surveys and abandoned the reveal preference data that they had. And then I suggested that they should be trying to estimate reveal preference and stated preference data together to handle, for lack of a better term, the hypothetical bias that might exist in stated preference surveys. Okay, so Dan Liu presented his paper from his Alaska survey during the conference, and after I finished talking, I went back to my seat, and I happened to be sitting next to Dan, and he said, "Hey, I've got this data that does what you want to use it for." And at the time, I had had my grant proposal rejected, and so I said, "That'd be great. Let's work on this." And we did, and the paper finally came out a couple of years ago in Empirical Economics. And so I took his data, we took his data and just compared a bunch of different joint estimation models for discrete choice data. Okay, and the models, there's several of these. Okay, the model that Adamovich used was a nested logit trick, and that came out in 1993. Mixed logit error component model came out in 2007, and then the generalized multinomial logit model came out in 2009 in a paper by Feibig, I think, and Hinscher expanded on that in 2012. So there's a bunch of applications of these models in transportation marketing and the health literatures. But in the environmental resource economics literature, the literature is pretty thin, I think. We've got the first paper in 1994, and it's got a ton of citations. People paid attention to it. Then Adamovich et al. Came out with another paper in GEAM in 1997. Instead of fishing, they look at deer hunting, I think, big game hunting. They're also using the nested logit trick. And there's a lot of citations to that model. The paper that Roger Von Hafen and Dan Fineff presented in the ARI session in 2006 came out in GEAM in 2008. They're using a mixed logit, and they're able to program themselves scale differences. They're accounting for the scale differences. And then, as far as I can tell, nothing happened. Well, nothing happened from not much happened from 1997 to 2008. So over 10 years. And then 7 years later, I'll build Troop. Apologize if I mispronounce your name. Olson and Stinger in Journal of Environmental Economics and Policy presented, as far as I can tell, the first application of the mixed logit error component model in environmental resource economics. And that's gained some, getting some sites. I've cited it several times. And the paper I just was pointed out after Dan and my paper was published in Empirical Economics by Cha and Melstrom in the Journal of Environmental Management, I think is the first to use the generalized multinomial logit model. And if y'all can find more papers that could jointly estimate reveal preference and stated preference data with discrete data, please let me know. But these are the only ones that I'm aware of at this time. So what we found in that paper was that if you use the most complicated model here at the bottom, this is generalized multinomial logit with this theta parameter. This is the parameter that captures the differences in scale between reveal preference and stated preference data. And typically you find that stated preference data has a greater variance. Okay, so this is our willingness to pay for a halibut, which is big old flatfish in that you can catch in Alaska. Okay, it's $42 per fish. And notice that the scaled model, naive, what I call the naive scaled model, a mixed logit model, they're naive because they don't capture the differences in scale, and then a generalized multinomial without capturing differences in scale. All of those point estimates fit inside the confidence interval, so we don't find much differences. And then the mixed logit, the ECM mixed logit, like in Bill-Troop, comes in with a value that's a little bit lower. The nested logit trick is even lower. And then you can see the separately estimated models have the confidence intervals contain 0. Okay, and that's partly because we've got a small sample size of about 200 anglers in this paper. So that's where I was about the time that this report came out, which was December 12th. And the report goes beyond the Whitehead and Liu paper. We're using South Atlantic and Gulf of Mexico data. Okay, we have a larger sample size. Instead of 200 anglers, we have almost 2,000. And we're going to test this data fusion approach. So in Whitehead and Liu, okay, we constrain all the parameters to be equal. Okay, the thing that they told us we could not do at the 1996 ARID workshop, we constrain them all to be equal. Okay, we're agnostic about which data source is the best. Okay, both of them have problems, and so we just constrain it all to be the same and compare these models. Okay, so we're going to test that approach in this paper. Okay, so the data, here's the governance of marine fishing in the United States is through regional councils. And so our data pertains to the South Atlantic Council over here in North Carolina, South Carolina, it's the states of North Carolina, South Carolina, Georgia, and Florida. And then the Gulf of Mexico Council contains the west coast of Florida, the small coastlines of Alabama, Mississippi, and Louisiana. And then Texas is not part of the data collection effort. So they're not included in our data. And just real quick, some policy background. We're looking at red snapper, and the policy issue is the allocation of the quota. Red snapper and all these species have quotas, and they're allocated between commercial and recreational fish. So most quotas in the United States are based on historical landings. 10 years ago, the Gulf Council said, you know, it would be more efficient if we allocated more of the fish to the recreational sector. Then the commercial sector sued, and a court order said, no, you can't do that unless you do some more work. And these councils have been thinking about how to do this for the last 10 years. And again, real quick, just allocate. The idea is that if you have, what we're trying to do is estimate this downward sloping line from the northwest to the southeast, the wills to pay for recreational fish. And if that is greater than the wills to pay for a commercial fish, which is the line that slopes downward from right to left, then where those two intersect is the efficient allocation. Okay, so in our report, we did estimate the commercial value along with the recreational value, and trying to come up with what the efficient allocation should be for several species. And the problem that I'm worried about is if you just use the state of preference data, okay, if it suffers from hypothetical bias, or if the coefficient in absolute value is too low, then the wills to pay is going to be biased upwards, and the concern is that too much of the quota might be allocated to the recreational sector. So this is the result that we find. Okay, so allocation studies, just review, can use either RP data or SP data from a discrete choice experiment, a DCE, which we call them. The National Marine Fisheries Service has a long history of calling these stated preference choice experiments. So that's the language that I'm using today. And in this paper, we're going to combine that RP and SP data. Okay, so This is a discrete choice study. So the random utility model for recreation uses information on fishing sites and the choice of which site to go to. And the independent variables are usually trip cost and attributes of each site. So with RP data, this is usually what you're stuck with. RP data can be very limited. In the marine fishing context that I'm in, the catch rates are measured as averages over time, limited to historical variation. You can estimate household production models for each angler, but in some other previous work with a couple of these folks, we found that you can't always estimate household production models to predict catch for an angler. There's measurement error, there's endogeneity in the catch rates, and then there's multicollinearity in the catch rates. Okay, and at some sites you're catching a lot of grouper, and at the same time you can be catching a lot of red snapper. And then in a lot of male surveys, there's recall bias. We don't have that problem in this paper because the catch rates that we're using are from a creel survey. Okay, so if you add in your state of preference data, okay, these two lines on the right represent the additional flexibility that you have with an RPSP model or with an SP model in general. Okay, you can add in new alternatives with new attributes, for example, bag limits or catch limits or size limits. And then you can also add in the don't fish alternative. Reveal preference data, you can have a don't fish alternative if you estimate one of these repeated run models, but the data that we have from the National Marine Fisheries Service is the most recent trip. So we have only information on one trip. Okay, and then the limitation of the state of preference data is hypothetical bias. These days, we might call that attribute non-attendance, where survey respondents don't fully focus on all the attributes. And the one that I'm most concerned about right now is when survey respondents don't fully focus on the cost variable. Okay, so then gains from combining these data is that we can we can deal with a lot of the problems on the catch rates in the reveal preference data, and the RP data is going to ground our hypothetical choices with the real choice behavior. Okay, so finally to what we're doing in this paper. We're using data. This is a website that you can't find anymore from National Marine Fisheries Service, where they laid out all of their state of preference survey data. We're using data from the Southeast and way back from 2003 to 2004. This is the data that David Carter and Christopher Lee used in that 2012 paper. Okay, in our report, we also use this 2009 data, but it's much smaller size, sample size. In the RP data, it's from what used to be called the Marine Recreational Fisheries Survey, the MERFS, and they became rebranded to the Marine Recreational Information Program. It's an intercept survey. You can see on the right in the Southeast until you get to Florida, there's 350 fishing sites. And then Florida to Louisiana, the state of Louisiana, in the Gulf of Mexico, there's over 1,500 sites. Okay, so that's a lot of sites for a run to handle. So we aggregate those to the county level, which is what's been done with these data since the early 1990s. Okay, so like I said, we have one RP choice, and for each angler, we have between 2 and 19 fishing sites that they're choosing from. We use a 150-mile cutoff to limit the number of substitutes. The catch rates we have are 5-year historic averages for both catch and keep fish and catch and release fish. And then the trip cost, it includes the variable cost, the cost of travel. It does not include the opportunity cost of time, because I think that The stated preference choice experiment does not include that in their cost variable. So we don't include that in our reveal preference trip cost. We do include fixed costs, which is kind of a no-no. But I think fixed costs are included in the stated preference choice experiment description of the cost. And so we're trying to keep these as close as possible. So one concern is that the trip cost in these two data sets do not match up perfectly. But they match up better than the Whitehead and Liu paper that I discussed earlier. Okay, and then the stated preference data. This was collected with a mail survey of anglers who were intercepted in that MRF's creel survey, and they received responses from over 8,000 anglers. So there's, and each survey has 8 choices that the anglers make. And then we, it's a mail survey of private boat anglers. And so we went through all the ID numbers from the MRFs and all the ID numbers from the mail survey and matched those up, and we lose about 75%, but we're pretty confident that the reveal preference and the stated preference data do match for these 1,928 anglers. So here's what the choice question looked like. Again, this was from the early 2000s, so maybe we wouldn't do things like they did back then, but they did a pretty good job with these data. There's 2 trips and a no trip alternative, and the attributes are target species, total number of target species caught per trip, a bag limit or limitation on how many fish you can keep, minimum size limit. Okay, and then the number of fish that you caught above the minimum size that you're going to have to throw back, and then a trip cost. And the trip cost includes your personal share over here on the left. It was explained personal share of the costs associated with gas, wear and tear in your vehicle, tolls, ferries, parking, access, fees, food, ice, bait, and fishing equipment used on this trip. So we went into another survey that the National Marine Fisheries Service did that calculated those expenses, and we tried to match up the expenses geographically for each of our anglers so that these trip cost variables would be as similar as possible. And this is table 1 from Carty and Leese that just shows the different levels of the attributes. So it was a very complicated choice experiment, I think, especially for the day. Okay, so here's the means with the RP and SB data. So you see, but we did get the cost in this first line. The reveal preference average of the trip cost is $106. The stated preference average is 90. So we got pretty close there. But all of the catch rates, we got dolphin fish, grouper, a grouper aggregate, then the red snapper and king mackerel. All of those harvest rates or keep rates are lower. The actual rates are lower than what was presented in the stated preference choice experiment. And then the catch and release numbers are also lower. So there's a difference there. The stated preference data includes a catch of other fish. The average is 3, but we don't have that for the reveal preference data. And then because we're aggregating up to the number, aggregating the sites, intercept sites up to the county level, we include the a number of sites variable to capture the fact that counties with more sites are going to have more trips, and the natural log of that is included in the recreation demand model. And that's been done for almost 30 years now. Okay, so conditional logit model, just to review that, we've got a utility function with the scale parameter, the sigma, and that becomes part of the coefficient vector. And so the probability that someone is going to choose a site J, probability of I sub J, so be a sub J there, is a probability of the utility at site J is greater than the utility at site K. And then the familiar logit probability, conditional logit probability, is this last equation with the scale parameter included in there. So I've got a bunch of tables of regression results in the paper, but in this presentation, I'm going to, whoops, that slide is out of, here we go. So the conditional logit model. So I'm just going to present, we're just going to look at red snapper, fish kept and fish released. So here you can see the same pattern of reveal preference cost and stated preference cost coefficient estimates that Adamovitz et al. Presented in 1994. Okay, in absolute value, the stated preference cost coefficient is much lower than the reveal preference cost coefficient. And then other problems show up in this conditional reveal preference conditional logit. The red snapper harvest coefficient is the only one that is statistically significant at the 0.05 level. Okay, I'm not a P equals 0.05 economist, but with the data set this large, I think that's a reasonable cutoff. A couple of them are marginally significant, maybe at the 10% level, but the rest of the coefficients aren't even close, and some have the wrong sign. But you don't get that with the stated preference data. You get nice, you always get nice statistically significant attribute coefficients. Okay, so now let's go back. So the willingness to pay is estimated in the typical way. It's the ratio of coefficients using the shortcut formula. Okay, and the, oh, I did that wrong. This should be beta. This is one of my my edits this morning hurriedly. So beta is in the numerator and alpha is in the denominator. So the cost coefficient, that alpha, has a big impact on these willingness to pay estimates. So here's the conditional logit willingness to pay per kept fish. You can see that for most of the species, except for dolphin fish, the stated preference willingness to pay estimate is much larger than the reveal preference estimate. Okay, and even though the conditional logit model has its problems, this is the pattern that we're going to see for the rest of the models. And I should say, on the vertical axis, we've got willingness to pay in the scale up to $90. We're going to see two more slides like this. The scale stays the same. So you can maybe get a feel for how these willingness to pay estimates differ across these three sets of models. Okay, so preference heterogeneity. This is a fairly familiar slide for a lot of people. The mixed logit model, okay, captures preference heterogeneity with this eta term, okay, this deviation or standard deviation or deviation from the mean. A scaled model, this is what Jordan Louvier talked about in the ARI session in 2006. He said we can estimate different coefficients for everyone in the sample. I was like, what in the world? And then he was talking about the scaled model, where the scale is, you can estimate these different scale factors in this scaled conditional logit model. And then generalized multinomial model combines the mixed logit with the scaled model. And this is the, I think it's the type 1 version of the generalized model, where the gamma weighting parameter is equal to 1. And so we don't scale the standard deviation term to eta here. And that's, in my experience with the data I have, that's always, it's always easier to estimate when gamma is equal to 1. And then the scale parameter in the generalized model, and I'm using in the logit software, which used to be known as limdep, and the functional form for the scale parameter is this tau, and the unobserved scale heterogeneity is this W variable, and then we're able to estimate how scale differs with the SP data with this theta term. Okay, so here is the results from the jointly estimated model, and what we do is we relax the data fusion assumption that the coefficients across the models are the same. Okay, when we do this with the catch rates, the coefficients look to be different, but the constrained model performs no worse than the model with different coefficients. So we're constraining all the catch coefficients to be equal. And here we have a separate model where you see the same pattern with the cost coefficient is much lower in absolute value than the reveal preference cost coefficient. And then when we constrain those to be equal, unlike Adamovitz et al. Back in 1994, our cost coefficient is closer to stated preference, but it's in between the stated preference cost and the reveal preference cost. And this is the same result we get with the Alaska data, but that paper got to be too much and we did not include those results. So it's the same pattern that I've seen at least twice before, and now the third time. And then all of the catch, the harvest, and the catch and release coefficients are statistically significant. Okay, so here's the willingness to pay per kept fish. You see the blue bars on the left, the ARP reveal preference, are much lower than the red bars in the middle. And apologize to people who are colorblind. I should have put the patterns on these bars, but the stated preference is in the middle. And then the jointly estimated, the constrained reveal preference to be equal to stated preference, willingness to pay, is on the far right. And that's always some weighted average of the reveal preference and stated preference numbers. So before I get lost in just plowing through the results, it's these high bars in the middle that I'm concerned about. I'm worried that people in that choice experiment aren't paying as much attention to the cost of the trip as they could be, and that's leading to this maybe upward bias, hypothetical bias in the stated preference willingness to pay estimates. Okay, so that leads us to attribute non-attendance. Okay, Dan Liu, same guy, and myself, we co-edited a special issue of Marine Resource Economics that came out last year on attribute non-attendance. And we have a review paper in that where we talk about the different types of models that have been estimated for stated attribute non-attendance and inferred attribute non-attendance. In this introduction, we do a very simple meta-analysis where we find that wills to pay estimates that aren't corrected, don't account for attribute non-attendance are about twice as great as willingness to pay estimates that do account for attribute non-attendance. So that's a big difference, and that number 2 is statistically different from the number 1, and so we think that attribute non-attendance does have an impact, and that's for studies that are estimating environmental amenities, or a bunch of studies that estimate food safety, and for whatever reason, maybe it's because those are mostly use values, we don't find any differences when researchers use attribute non-attendance. Okay, so here's just a picture from that article that where we tried to present a diagram of all the different models that are estimated with stated ANA, and here's the same thing with inferred ANA. So there's a bunch of different variations of how to do this. Stated ANA, I should say, is when you ask the respondents, well, what did you pay attention to and what didn't you? And then you use those answers. And then inferred ANA, it's usually done with a latent class model where you try to figure out different classes of respondents that may not be paying attention to different attributes. Okay, so our data is limited. We're using the quality constrained latent class ANA model that was used by Ketzi in Journal of Environmental Economics and Policy in 2017, where he only focused on attribute non-attendance for the willingness to pay estimate. And when we do that, we have 2 classes, one with the cost coefficient, one with the cost coefficient constrained to 0, like you see in these 2 utility functions below. And we found that there's 79% of the attributes might be sorted into this non-attending class. And that's
Can I ask a quick question on it?
Yes.
Sorry to butt in. I'm just trying to get my head around this idea of attribute non-attendance and what it means. I mean, the obvious question is, how do you distinguish attribute non-attendance from preference? So you're assuming that people do have preferences over these things in the stated preference, but they choose not to express them? I mean, what does it mean in terms of behavior? What are you assuming about how people respond to these things?
Yeah, and So yeah, that's one of the things. That's one of the issues that people are dealing with in this literature. It might be that people just don't pay attention to cost, don't pay attention to grouper, or it might be that they don't care.
What do you mean by don't pay attention to? I'm just trying to get a
Yeah,
feel
when you're
for what
looking
that
at
means.
when you're looking at the survey on the on
Yeah.
your screen or the mail, then it's a decision heuristic, and you decide to simplify the choice task by focusing just on how many fish I'm going to catch and not worrying about the $25 or $30 difference between those two trips. And embedded in this graph, we have, let's see, the attribute on the far right at the bottom, the attribute elimination model, and the ANA validation model, where those two hypotheses may be tested against each other. And it turns out that it is sometimes found that it's not that respondents necessarily aren't paying attention to the attribute, is that you find different classes who might have different values for that. So that's an unresolved issue.
Yeah, sort of. I find it difficult to know how one could. I guess you're asking them, aren't you, in the stated?
In the state,
How one could say that that's non-attendance as opposed to just non-interest, or just I don't have a strong preference over that particular factor, or that's my real preferences. You just happen to think it's not. Those seem like really difficult things to distinguish.
Yeah, and in an
empirical way
model, then we've got this confirmatory versus exploratory. I think the confirmatory model is the one where you constrain the coefficient to be equal to 0 in different classes. And the exploratory is you just allow the latent class coefficients to be estimated and then find the ones where the margin utility, the attribute coefficient is close to 0.
Sorry, John, to interrupt. I just wanted to let you know that we have 11 minutes left. Do you think that's
11.
Fine?
That's great. My clock says 4, so 11. Oh, 11 gets us to no. Yeah, okay.
Yeah, 11 to the full hour. Yeah.
Yeah, I'm going to try to finish up in 4.
Perfect. So we have time for questions. Thanks.
Yeah.
Thank you.
That's a lofty goal. But so what we're doing here is I'm thinking of this in terms of benefit cost analysis or some other types of policy analysis, where I'm going to be hard-nosed about how we're dealing with ANA, and I'm going to come up with a range of estimates, and I'm going to lean into sensitivity analysis to help decision makers make a decision. So I'm not worried too much right now in this paper about what the ANA means, although that is an important question. Okay, so what we do is we're going to take the probability from the latent class model that someone would be in the non-attending class, and if that probability is greater than 50%, in the models that I'm going to present next, we're going to constrain those coefficients to be equal to 0, that cost coefficient. So basically, I'm estimating the stated preference cost coefficient with only 21% of the survey respondents. Okay, so here's what that model looks like. You notice that the cost coefficient is about double from the model without attribute non-attendance. And then the absolute value of the constrained coefficient over here on the right is about 50% higher than in the model that does not consider attribute non-attendance. Okay, and so the willingness to pay per kept fish, the numbers go way down. Remember that the height of this figure is constant throughout this talk. And so our wills to pay estimates are much lower. And part of that is because the catch coefficients fall. I'm not sure why, but they do. But we still have the same pattern that we have lower wills to pay estimates for revealed preference, higher for stated preference, and the constrained is a weighted average, some sort of weighted average. Okay, so the way I like to think of this is think of this in terms of a triangular distribution where the number on the right, we've got a flat triangle and a steep triangle. The number on the right, the highest number, and the wills to pay on the vertical axis. The number on the right is the stated preference estimates. Okay, at the base, the number at the base on the left is this reveal preference estimates. The one on the right is the stated preference, and the height of the triangle is the constrained estimate. And so you can see that the constrained estimate is, again, a weighted average. And then with attribute non-attendance, the range of those numbers becomes much smaller. And in this way, this is the way that you might be able to use sensitivity analysis to use this range, all of these estimates in some sort of policy analysis, in this case, an allocation analysis. And that's what we did here. This is a screenshot from the report. And the blue line is our willingness to pay for recreational fish. And we call the red line the one that's upward sloping from left to right, the marginal cost of allocating quota to the recreational sector. Okay, so if you don't adjust for, if you only use the stated preference data, the models tell you that all of the fish should be allocated to the recreational sector. And if you do account for, if you do use a jointly estimated model, some of the quota should be allocated to the commercial sector. And I should say that this is just an illustration because there's lots of problems with these data that you would really not want to do policy analysis with in this day and age. But this just illustrates the impact of joint estimation. Okay, so my timer went off and I'm to my conclusion. So I'm a little bit over my time, but this will be quick. Conclusions, a typical conclusion in one of these papers, there can be significant gains to joint estimation, increased efficiency, you can deal with some biases, you can, stated preference data is more flexible than reveal preference data. That's not necessarily something that comes out of joint estimation. And sometimes you can estimate the decision to stay home. Okay, but there's a lot of limitations in what I've just presented. First, you need to pay more careful attention to the cost variable. You need to use something like Adamovitz did in 1994. They had a distance variable instead of these cost variables where you have to define to respond what the cost is. I have a paper with Anna Lopes, who was a PhD student at University of Stavanger in Norway, I believe. And now she's working at a university in Denmark. And I was supposed to make sure I knew what that was, but I'm not sure at this point. But she has a paper that does this in a very nicely, it's very nice, looking at oil spills in Norway. And I think she has stated preference, reveal preference variables that match up perfectly. In the paper, in what I just talked about, the RP data is limited to the most recent trip, like I said before. Okay, one direction for future research is try to estimate the repeated trip model, where you can do an opt-out parameter. I think Anna does that in her paper. And I should say, Anna was gracious enough to have me as a co-author in that 2021 paper, a chapter of her dissertation. She got to spend a semester here in Boone, and we had a lot of great conversations about research. And then, does a scale parameter matter, at least in terms of estimating wills to pay? I don't think it does. It might matter in terms of efficiency of the econometric model and a lot of under the hood type questions, but in terms of estimating wills to pay, I don't think it matters much. And then finally, I think there's big implications for stated preference data. I'm convinced that most of the choice experiments that we do, there's hypothetical bias or attribute non-attendance in there. And at the least, researchers should consider to try to estimate those models and see how sensitive their results are to the assumption that people are paying full attention to the cost variable. And if you do find that problem, finally, the problem can be mitigated with joint estimation or attribute non-attendance approaches, or both. And so thank you, and there's my email in case you have some some of the more difficult questions, I invite you to send those to me via email.
Brilliant. Thanks very much, John. Great presentation. I think we can now use the final few minutes to open up for questions if there are. I think Ian has a question.
No, I was clapping actually.
All right, sorry. I never recognized.
No, it's right. I've got 10 minutes with John afterwards, so I'm not going to ask any questions.
Okay, so let's see. I think Brett has a question, or is it from before, Brett? Oh, you're muted as well.
God, it's so confusing. It's well beyond me. Thank you, John. That was really interesting to hear and great presentation. So I'm still getting my head around what you're trying to do here. And there was a certain element of, it seemed to me that you trusted the RP results, but not really the SP results. And that some of what you were trying to do was to try and recalibrate the SP results so they look more like your RP results. Is that the feeling of what was sort of driving your research doing that?
Yeah, I would say in this narrow area, marine recreational fishing in the Southeast United States, and I've used these data since the late 1990s. I do trust the reveal preference travel cost parameter more than I do the stated preference travel cost parameter. I think it gives us a pretty good indication of what people are thinking when they choose sites. And if you look at the reveal preference data, it's like 85% of all of the anglers who choose a site go to the site that's closest to their home. So that's what's really driving that. And I don't think that's captured as well in the stated preference data.
Yeah, and particularly because the sort of stated preference you were doing doesn't have any sort of geographical context to it. It's just a cost. So not thinking about a particular place. Well, that sort of just leads to the question of, well, why not just use RP data? What is SP data bringing to this that improves things if we have to just recalibrate our models to try and get it to fit with the RP data?
Yeah, then I go back to the, at least for this data, this type of recreation data, a lot of times that trip are better estimated with the stated preference choice experiment. You can break the multicollinearity and homogeneities and all those econometric problems that show up in the reveal preference data that really makes it difficult to estimate, at least in this context, the coefficient on the catch variable. I've got a 2012 paper with Tim Hab and Kurt Schneer and Rob Hicks in Marine Resource Economics that marches through a bunch of models that, and we have trouble estimating that coefficient.
I won't keep hogging it, so I'll keep passing over. Thanks, John.
Yeah, I've seen another question from Paul in the chat. I don't know, Paul, if you want to ask it yourself or...
Yeah, sure. Yeah, we'll do. Yeah, great talk. Thank you. The conclusion that you reached about stated preference being overvalued, I wondered if it might be the case that the reveal preference might be undervalued. Perhaps if people aren't paying attention in the real world as much to catch rates, which they care about, but they're just not as aware of as they ought to be.
Yes, it is possible that reveal preference is underestimated. And that's what I'm thinking with that triangular distribution. If I was to use these estimates for policy, the distribution puts a probability of 0 that the reveal preference estimate is true. And it puts a probability of 0 that the stated preference estimate is true. And it's going to grab estimates along that range. So yeah, I'm not as strident as I sounded during that the reveal preference estimate is the accurate one. And most of my research throughout the years has focused on contingent valuation. And yes, I'm a fan of stated preference research, and I think it provides a lot of information. But I do worry a bit that it is overestimated, and I think I worry a bit that reveal preference is underestimated. In this context, if we can estimate those values at all, which for a lot of those species, though the wills to pay, the bar that I showed you was not statistically different from 0.
Brilliant. Is there any other question or comment that people want to share think we can take maybe 1 or 2 minutes, if John is fine with that.
I'm fine with that. I apologize for going over time.
No worries.
Can I keep following up then? If no one else is, please butt in. So
Yeah,
is there a sense in which we think SP might be better at looking at certain things? And one of the mistakes we're making is to try and make people think about travel costs in SP, when clearly that becomes a very difficult thing for them to process and imagine, but potentially thinking about how they respond to catch rates in advance. So SPs which don't try and do trade-offs across so many dimensions, I think we're pretty clear now that people really struggle when we add dimensions to these things, and concentrate on things where we want to deal with collinearity problems or want to predict out of current ranges for policy regions. So something which tries to design the SP in the context of making it fit with RP might be the way forward, rather than just doing these two things separately and then trying to merge them. Do you think that might be a conclusion you come to?
Yes, that's a great comment. The two data sets that I've talked about, neither study was designed to do this sort of work. The data that I talked about today is all these attributes, all these levels, and I'm sure we're using for an angler. The choice experiments, the surveys that I write myself, I'm using referendum questions, so only yes or no, and just I try to limit the number of attributes. So I agree, and one of the future research points that I wanted to bring out was that let's design studies to try to test this in the recreation context or in the use value context, like I'm doing here. And I didn't even mention all of the environmental and other choice experiments that are being done that capture total values and use values and non-use values. And in those, there's no way to, as far as I know, there's no way to jointly estimate with reveal preference data. So
I'm glad you said that, John, because you were mentioning papers that have done this, and there's a few of us who've written a paper went out in June last year. Can't remember now, 2019, I think, which tries to do exactly that, to use revealed and stated to separate use and non-use. I can send you a link if you're interested.
Yeah, all right, I'm gonna write a note to myself and I'll find that.
Shameless plug there, sorry about that.
I haven't seen it yet. No, I asked for studies that I had missed earlier, so I appreciate
Brilliant.
that.
I've seen one last question in the chat.
I can see it, so I can read it.
Okay, perfect.
Yeah, so the question is, if you're only using choice experiments, then what should we do so that the values will not be overstated or understated? So in that case, when I do my own work, I always check the attribute non-attendance models. You don't have to ask a stated ANA question in your survey to be able to check for attribute non-attendance. And in that way, you can at least get some information on with the hard assumption that people just aren't paying attention to your cost coefficient. And you can do do a robustness check, your choice experiment model with ANA, without ANA, and at least report what you found in a footnote. And that's what I'm asking when I review a paper that doesn't use ANA. I ask them to at least acknowledge that the issue's out there and think about what they might do going
Not
forward.
a concern. Yeah. Sounds brilliant advice as a conclusion. But thanks a lot again, John, for the great presentation. Thanks everyone for joining as well. Just a quick reminder that we have 2 other LEEPout seminars scheduled. One for the 17th of June. We'll be hosting Andreas Contoleon from the University of Cambridge, and the other one on the 15th of July with Amy Under from the University of Illinois. So thanks again, everyone, and have a nice rest of your evening.